Hey everybody, Tech Talk Tuesday number 170 today. 170. Let's see where I put my water. We've been 170 weeks. It's here, hey Charlie, here it is. It's, oh my gosh, what is this? After Halloween, Tech Talk Tuesday. This is 6 o'clock on Tuesday evening in Eastern time, and here we are Central, and I am going to find my water because I'm thirsty and I got a bottle. Hang on one second. I got it. Sorry about that, everybody. Tech Talk number 170. Hey, Ron, Ray, I got my 0 weight lubrication for the pipes. Alan, Ray, thank y'all. A couple things I wanted to share with you today. The other day, I showed you the S&S lifter cuffs for us to put on the Milwaukee 8. And everybody's asking me, so well, if the stock one does the same thing, if it locates, what does this one do? Well, this has a relief machined in it, which maybe I can get the light to show you. I got it coming up. Here we go. Let me get this light. There we go. Right there at 6 o'clock, you can see it's got a little relief that allows the lifter to go up in there higher. Hey, Ben. Hey, Zachary. So I wanted to clarify that with you. This is not just a replacement made out of billet. It's anodized for strength and durability to hold the lifters true, because on these hydraulic rollers, you know, they're made for the wheel to follow the lobe, and if the lifter twists in the engine, it will break the wheel off and wear the lobes out. So this needs to be, when you're going to put more than, let's see, the 3030 works great with 485 lift, and the F35A has 572 lift, and it'll jack the lifter cuffs up when the cam lifts it up. So you got to put these in that have the clearance machined in the back of them for the lifter to go higher. Let me grab one and show you. When you put the stock anti-rotation device on, you know, you'll end up with a situation where it won't let this go up in there high enough. So you can get more lift out of it. Also, a lot of folks don't realize how little lift a Milwaukee 8 really has. Like a 585 cam, let's say the 3030, it has a 485 lift, but it's only a 3.303 lobe lift times the rocker ratio on a stocker, somewhere between 1.6 to 1 and 1.61 to 1. See some compensators back there, yeah, don't you? So with that ratio of 0.303 lift times the 1.6 or the 1.605, whatever that rocker ratio is, we come out with somewhere between a 480 and a 485 lift, and it's just math. But another thing I was wanting to share with you guys today is the Blue 5.0 is, I'm getting ready to put it together, and I wanted you to see this is a 4.6 bore ring. This is a really big ring. This is a Napier oil ring from Total Seal, and I'll draw it on the board and show you what it is. But I wanted you to, hey Ricky, hey Brandon, hey Cash, I just wanted to share with you guys that when you have a ring this big, it's only 4.6 across. And I know I need a caliper to do it, but this will show you. It's about 4.6 bore, which is the same as like a big block Chevrolet or whatever. But I wanted to tell you that if you took this ring right here and you straightened it out and made it into a straight piece of wire and stretched it way out, we would end up with a 14-inch long piece of wire. And it seems like when you end gap them, it doesn't seem like it would matter that much if you've got 14 inches of wire circumference here with only a 4.6 bore. And this is a good challenge for you guys. There's a bunch of folks talking, and I'm live, so I can't really stop and do it. But figure me the circumference of a 4.6 bore. How far is it on a 4.6 bore all the way around the perimeter? And tell me how long this wire is. And I'm going to talk to you about that for a minute. But this is a good challenge for you. You got a calculator? Tell me the circumference. We got to know the radius, 4.6. I think the radius is, what's that, 2.3 is the radius of the bore. And figure the circumference for me and then post it up here. Hey, Lloyd. Hey, Harvey. Charlie. Thank you. See, you can hear me loud and clear. All right, somebody do that for me while I switch this over to the board, and we'll talk more about this. Here comes the board. I'm switching over now so you guys can see it. Jack pi times diameter, yeah. This is the part I wanted to share with you guys right here. Check this out. 170, man, that's 170 weeks. Good grief, 170 weeks. Also, I know it's not on my diet, but I got my Cheez-It socks on. If you guys like Cheez-Its, that doesn't fit my diet, but we have a good time with it. On time, finally, watching from hospital parking lot. My son got welded slag, and I thought, oh my gosh, stick welding. 14.4. Thank you very much, Chuck. That is a great answer. 14.44. All right, let me show you what that means, just so we can see some cool relationships. Here is the ring, this 4.6 in diameter, okay? If you were to take this ring and straighten it out and make it into a straight wire, this wire would be this long. So what's important about what I'm trying to tell you here is when this ring sits on the top of this piston, the oil ring goes in this groove right here, and the top compression ring goes in this groove right here, and it's the closest one to the fire. And everything from this ring up, from this top ring up, is unbelievable heat and pressure. Matter of fact, the only thing that cools this piston off, really, other than a little bit of oil spraying on the bottom of it out of the piston jets, a little bit of oil makes it a little cooler from the bottom. But look, if the oil's 200 or 300 degrees, which you know it is, spraying up in here, this up in here, this is so hot, it's crazy. This is, just the exhaust pipes are 1,500 degrees. So our temperature in the combustion chamber is somewhere between, it's 1,000 degrees easy, somewhere up in here. Localized, 500 degrees maybe on the intake side, maybe 1,000 degrees on the exhaust side, but the temperature in here is really hot. And this ring right here, the top ring and the second ring, takes that heat out of that piston and transfers it to the cylinder wall to let the heat out of the piston. So, because this is the hottest part, this and the exhaust valves. But what this is important, I want to tell you, is this is a piece of ductile iron right here. Let me see what it's made out of. I'm pretty sure that Total Seal made this out of a piece of ductile iron, but this is what I wanted to tell you. This piece of iron right here, or this piece of wire, this piece of steel, this piece of ductile iron, whatever it is, it's 14.4 inches long. That's almost 14 and a half inches long. When you heat that up, this ring gets longer and longer and longer and longer, and it will grow 20, 30 thou in length just because of the temperature. Now, what does that mean to you and me? Well, if this ring grows in length, that means that this gap we have on our piston, even though we set it at 4 thousandths per inch of gap, I'm going to grind it 4 thou per inch. Even though this ring end gap, they call this the end of the ring and this the end of the ring, and I ground it with my ring grinder right here. You can see how I ground it right here. And when I get this from total seal, it comes in at 4.605, which means it will not even fit in the bore. It butts. So you have to grind these. So if you're buying these cool pistons and these cool rings and the cool cylinders, and you get your cylinders honed out to your piston size and you get your rings made to fit, you better check this right here, because if they make it to where it bolts in and this has zero clearance right here, when this hot rod gets hot and it starts growing 20, 30 thou in length, think about it. That doesn't seem like this ring would get longer and close this gap up when it gets hot. But if you turn it into a 14-inch long piece of steel material, this ring right here grows in length, okay? I hammered that long enough, but I wanted you to understand that's why we have to measure the end gap on the rings. Couple ideas. One, here's the cylinder. Two, this is the grinder. Has a carbon wheel right here. And it has this really nice, high quality, adjustable kit right here where I can move the ring. And I'm gonna set it in here just to show you what it looks like when you do. I hope you can see this okay, and I'll turn this light around where it makes a little more sense. I'm going to rotate it to where this ring is up against this wheel. And you can turn this on. And it's got to be nice and square, and I'm going to show you about that too. If you can see, there's a tiny little gap at the top. So that means I need to move the ring just a teeny bit this way, which I can adjust with this adjustment right here. Now I'm going to set it in the bore. Pay attention. I'm going to square it up. This is not the best ring squaring tool, but it will work for our video. And I'll look and see this gap. And I'm going to measure it for you right now. I like 4 thou per inch of bore width, normally aspirated. So I know it's really little, so I'm gonna get me a little baby, little feeler gauge here. Let's see if I can find a little one in my stack. Here's 3. I'm gonna use 5. Here's a 5 thou feeler gauge. And 5 won't even fit, y'all. That's how much got to grind off of this thing. When I got the ring out of the bag, out of the Total Seal ring bag, it was butted so hard I couldn't even square this ring up in here. So I'm trying to tell you this so you don't just install them and hope that your engine doesn't blow up. But the calculator says that if we're normally aspirated, and I'm going to run 4 thou per inch of end gap, I'm going to say 0.004 times the bore of 4.6 equals, that's 18 thousandths end gap. So that means I got to find an 18 thousandths feeler gauge in this stack all the way up to 18 to 19. And I'm going to keep grinding this ring on this machine and keep checking it 1 or 2 thou at a time. And it also, this particular machine has a really nice deburring wheel here. So you can it's really fine, and you can deburr the edges of the ring so you don't have a sharp edge on your ring to snag on your package there. So it works out really nice. I'm not going to spend this whole video showing you how long it takes to get a ring that comes in from the bottom, that says Yes, ductile Napier. Sorry about that. See where it says 4605? So 035 too. Got a, let's see here. I have, it's 125 radial. It's 035 2 axial height and a 0.125 radial height. And this piston is made specifically for us to fit this ring, where this oil ring will go right in here and have the depth it needs to have very little back clearance behind it and very little side clearance. And on my particular engine, I'm going to run 18. This is my engine. I'm going to run 0.184. So that means I'm going to keep cutting it till I have a 0.19 feeler gauge goes in there nice and tight. So I wanted to share that with you about the cuffs. I wanted to share that with you about the rings. And if you do a turbo or a nitrous or supercharged engine, this 14.4 inch long piece of ductile iron is going to get longer and longer yet. So we will go all the way up to 6 thousandths per inch, which gives us, because we're going to grow more with more heat. Turbos give you more heat. Superchargers give you more heat, and nitrous definitely puts more heat in here. But this engine will be able to run the bottle if we want to, just by making sure that we put enough end gap in it so that the rings don't butt. And I'm going to tell you what happens when you butt the rings. But let's say I wanted 6 thou for a nitrous engine, I would do, let's see, clear for 4.6 times 0.006 equals, that's 27 thou end gap, and that's still not enough for some people. There's a lot of people with nitrous engines that run way more end gap than that, but that allows us to grow from 18 thousandths end gap all the way up to 27 thou end gap, and allows us to let the wire get longer to where the rings won't butt. Now, if you put this together with not enough gap right here, if you put this together to where these two parts touch each other, what's going to happen is this is going to bottom out in the piston, and it's going to create a ton of burning and welding, micro welding on the back of this ring, and it's going to bottom out in here because it will be, the ring is too big for the bore. So you got to make sure you cut the end gap on this. So if you've got a guy building your engine now, you get a stage 2, stage 3, stage 4, or stage 5 from Harley, I'm pretty sure they come with all this stuff already done for you. And that teaches us Harley technicians to not worry or measure this stuff. That's why I spent all that time showing you how to check deck height on the top of the cylinder so we could get the piston clearance right. And I had many Harley techs and engine builders and assemblers send me messages and emails, say, why are you checking deck? What does that do? Why do you need that? Well, we want the piston to get as close to the head as we can without hitting it. So we have to set the deck height to where the piston can run all the way at the top, because we want this piston close to the head on the quench areas here, here, and here, so that we can create a bunch of mixture motion in here when the piston's coming up on compression, lights the plug, bang. The more we keep this homogenized mixture, the more the gas and the fuel and the air is mixed, we will create more power by generating a bunch of movement in here. And if it's far away, like you're trying to set the compression ratio lower by running a thick base gasket or a thick head gasket, and you move your head away, you're going to end up with not much mixture motion. Your efficiency goes down, your horsepower per cubic inch goes down, and this is going to be a normally aspirated engine that I'm going to try and make the most power for. Now, I'm just about to get too long-winded here, and I want to tell you a couple things. First of all, every week, will you build my engine? Listen, y'all, I'm retired. I work on my motorcycles now. I work on my cars, and I work on my motorcycles. Yes, I do Tech Talk Tuesday for people. Yes, I'm a consultant for many mechanics. I do consultant for race teams. But since I've done this for 45 years professionally, I am retired now. So I do it for fun. It's a hobby. This is not my job now. And I wanted to share that with you guys. You got questions? Email them to me, george@starracing.com. If I have time and it's a question that suits a project that I'm interested in, I will spend a minute trying to help you with it. But I just wanted you to know that that's why I'm not building engines anymore. I'm finished. I did it too long. Jackie and I went on our first 3 or 4 day vacation in 30 years. It didn't have racing involved in it. We got back Saturday. I'm glad I went. It was wonderful. But I love working on my hot rods, and I love using everything I learned all these years. But I want to tell you something about my stuff. I'm working on my stuff, and every week I'll give you a little update on my projects. But I wanted to tell you, many shops do this now. Back when I started, there wasn't very many shops that do the work that we did. And now, look at this. 15 years ago, any person that could get 100 horsepower at the back tire on a twin cam was a hero. 15 years ago, I got all the work I could do guaranteeing people 100 horse on their twin cams. That was a big deal. We even, S&S, Star Racing, and a couple other cool shops had 100 horsepower clubs 15 years ago. And I'm talking about 2005 through 2010. If you could do 100 horsepower at the back tire on a street bike, you were the man. 10 years ago, 130 horsepower, whoever could do that ended up getting all the work. But you think now, we're all here, we're all paying attention now, and we're saying 130 horsepower, good grief, man. You can buy engines on the internet and make 130 horsepower. Yeah, here we are, 2022. Did you know every shop can assemble 150 horsepower? Milwaukee 8s have made it dummy proof. You can buy kits, you can buy pistons, you can buy heads, you can buy cams, you can buy manifolds, throttle bodies, you can buy exhaust pipes, you can buy all kind of cool stuff right here. You can just go in here and type in 150 horsepower Milwaukee 8, and it will list 100 places you can get it. But that's not how it was 15 or 10 years ago. Now, 150 horsepower is easy. Easy. It's a bolt together engine deal, and you don't even need to know how to do deck height. You don't need to know how to end gap rings. You can just bolt it together. It's got all the safety built into it. It's got too much clearance for the piston to the cylinder wall. It's got too much clearance from the cylinder head to the pistons. It's got too much clearance for the pockets being so deep. Y'all, I see these Milwaukee 8 pistons on the internet that some of these companies are selling. It looks like everybody's cam.com would fit in it. They got the deepest pockets, and they got the biggest pocket diameters and depths, and it makes the efficiency go down. So if a guy was to detail these clearances, like get this perfect where the piston, and I noticed everybody talking to me about when I was checking deck height, my piston was going clunk, 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 clunk. It was moving 30 thou, but look, it doesn't have rings on it. It only has 4.5 here where I want it, but it has 30 thou clearance up here so that this can get really big without striking the cylinder wall. This part stays cool and doesn't burn. This part gets above this top ring. This hot rod cylinder, this ringland right here grows huge, and the ring gets longer and longer. So this gets bigger. The root diameter of this ringland gets bigger, and the ring itself gets longer. So you got to make room for all that stuff. And then, if you want to make it really go fast, all the pressure that when you buy the +2, +3, 1.5 millimeter oversized valves, you get some really nice heads from Ward and Moonshine, and you get them from V-Twin Power Sports and Ron Reese and all those guys that make the really nice Milwaukee 8 cylinder heads. You get all those really nice cylinder heads. If you have this ring where it butts while it's running, it's going to leak. All that pressure is going to leak. If you have this ring where you throw it in there and it's got too much gap right here, I want to tell you, man, when this gets 800, 1,000 PSI built up on top of this, it goes up, compresses, it lights, it goes boom. And when this ring has a big gap right here and the bore is crooked, the ring's going up and down in an engine like this 100 times a second, leaking, sealing, leaking, sealing, leaking, sealing. So you're not going to get the power that you could if you do what I'm doing. I'm going to push this. I'm going to get all my clearances right. I'm going to get my piston to valve to a minimum. I'm going to get my piston to head a minimum. I'm going to get my compression ratio where I want it. I'm going to get my piston to wall minimum. I'm going to get my end gap at 18.4 so that I don't lose any cylinder pressure by this end gap right here, so I can make more power than my competition. I just wanted to share those ideas with you. That's what's going on here. That's why I'm spending so much time on these seemingly insignificant little jobs that we read about on the internet that says end gap, piston to wall clearance, piston to head clearance. And I also got something really cool. I didn't do it because it was cheap, but it was really neat. I put a video up of this. Michael Beelan sold me a kit. You got a booster wheel off the internet, a booster wheel brake, and a booster caliper. Cheap. And Beelan at A1 made me this little kit with the hanger, with the little rod to bolt this on. And I got a really nice swing arm from Dave at CP. Nope, I said that wrong. Dave at Track Dynamics. And all of this goes on here. It'll bolt right on here, and it'll be 2 inches longer. And I hope I have enough clearance in here to hang this wheel back here another 2 inches. That's my goal. Stock rods, stock transmission, and it's going to make 145 cubic inches, and it's going to be a 4/600 bore. It's a big bore. It's a big piston, and it has really big stuff, big manifold. And I'm going to tell you, don't do it. Just because I have one set of 4/600 pistons, don't do it. They're not going to be for the highway use. They're not for touring. They're not for driving around on the freeway. You're not supposed to go to Sturgis or Daytona. You can't ride around in traffic. Don't go on parades. This is not for you. This will be for an experiment. I'm going to experiment and find a weak link on the Milwaukee 8, and I'm going to share it all with you guys. And I'm hoping that I can go and foot shift it and drive it to a 9.75 in the quarter mile with an old man driving. And that's what I got today for Tech Talk 170. I have a lot more to share with you, and I can't wait to sell you more, share you more. And I'm not trying, change that word. I'm not trying to sell you this. I'm not trying to sell you this. I am sharing with you what you need to do to make your 4.310, your 4.250, your 4.5, whatever bore size you have. This stuff is so important that you need to check around, ask around, and you need to get the work done by people that know how to make it work. And I'm telling you, you don't need to try and make something this big work, because there is no room in the cases. There's no room for the dial pins. There's no room for a base gasket. This cylinder has been heavily worked over to make it fit even in the case, and for the pistons to even fit each other. And I know you don't want to get into all that, because if you did a 4.5 bore, it would be a 143 instead of a 4/600 bore where it's a 145. Those last 2 inches are not really what you want to do. But thank you guys for tuning in. Thank you for paying attention. Thank you for following me all the these 170 weeks. I am so thankful and appreciative of you. I look forward to talking to you guys during the week, and looking out to see you for Tech Talk number 171 next Tuesday. Thank you for watching. May God bless y'all.